My name is Nelson Wittwer. This is my first time presenting at any sort of technical conference. Kind of cool that it's RubyHACK's first conference and I'm speaking here for the first time. I'm a Utah native. I've lived here for the majority of my life. I am a CTO at a small healthcare startup that on the one hand is way fun, and I will either be really rich or, man, I'm going to be really broke someday. Especially because I just found out that I was supposed to win that Millennium Falcon, and I was like putting out fires, and so add that to the list of, man, those stock options better be worth something someday. You're probably wondering a very important question based off of the title of my slide or my talk from the schedule. What am I doing here? Why did I bring a DevOps to a Ruby fight? And that is a very good question. Thank you for posing that rhetorical for me to start out. There are a couple reasons why I wanted to do this. One, because I needed to force myself to learn this stuff better. But most importantly, I was thinking of where I sat 5 years ago when I first started writing Ruby. So I kind of am a hybrid of the self-taught world / I came through the university setting. So I kind of did a start-stop, on-again, off-again relationship with code. And it's super confusing for me to put out all the pieces together. So I think it's really important for us all to know the DevOps side so that we can actually be able to know what it is that our DevOps brothers and sisters actually do for a living. So this is here to help you level up your game a little bit. I mean, Ruby is traditionally a back-end language. So if you need to have responsibility for running your code on the back end, you should probably know what that back end is and does outside of just your Rails app. And I also wanted to change this attitude. So I've worked at a couple of places where we were lucky enough to have a DevOps team, and unfortunately, this was very much the culture. And I think we're all guilty of this in one way, shape, or form of saying, you know what, man, I don't care if it's broken in production. It worked on my machine when I gave it to you guys, DevOps. This sounds like your problem. So by understanding a little bit more about how all of your code works in concert together with the server itself, you'll be able to have much more empathy with the members on your team. And I mean, we're engineers, we're here to be problem solvers. And if we can't give our team members the empathy that they deserve, then we've got big problems. And your problem solving abilities are limited because you guys hate each other. And then finally, to answer this question, and this is where I come back from me starting as a kind of a self-taught Rubyist, self-taught with the huge help of the community around me. I wouldn't be here without the Utah Ruby community. So, but I want to answer this question that every new developer who's ever gone through the Rails tutorial has ever asked themselves, okay, how do I get this cool app of mine onto the internet? It's one thing to see it on my computer, but I can't show it to my mom and say, hey, I'm actually doing something with my life. And I know how 9 out of 10 of you would answer this question, and it's how I answered it for the first 2 years of my career, and it looks something like this. Not to throw too much shade at my Heroku friends. I actually love Heroku, and for most of the time, this is your go-to. This is a great way to get up and running with your idea to validate it before you go and spend a bunch of time trying to get your DevOps stack working correctly. So outside of just git push Heroku master, you should be able to know what's going on behind the scenes. So who is this for? So the target audience for this, really just about everybody here, I'm hoping, can be able to get something new out of this, unless you're already a level 3000 neckbeard backend engineer. And if that's the case, awesome. I'm very jealous. My beard comes in patchy. So hopefully, yeah, we can all get there someday. So developers who've written your first app. So if you've done the Twitter clone and you want to know, hey, how can I get this on the internet? While this will be a very technical talk, I will try to explain it in a way that someone who can understand new concepts can learn it, can be able to follow along. So I hope to not lose those people. For seasoned developers who want to up their game, this is for you. If you've been burnt by trying DevOps in the past, I know I have several times before I had a friend who kind of showed me the light of how to correctly do this. And if the only way that if your gut knee-jerk reaction to DevOps is Heroku, hopefully we can teach you something new today. So our goal, or my goal, is to take your app and teach you everything you need for a 3-tier infrastructure. So we're going to have a load balancer, we're going to have web servers, and we're going to have a database. If that doesn't make any sense to you right now, it's all right, we'll get there. And hopefully, if I do a really good job, we will not feel like this when it's all said and done. I mean, there are right ways and there are wrong ways to learn new technologies, and the learning curve of DevOps, unfortunately, is pretty steep. It can be steep because there's a lot of rabbit holes that you could dive down, and it's no different from coding. I mean, for the first time that you learned loops, conditionals, all that kind of stuff, if you weren't taught in the right way, your learning experience for code could be very bitter, and that's how it was for me. So I learned how to code at BYU, and while they have a teacher who's spent their career in technology and knows code inside and out, you actually learn how to code from the TA who took the class the semester before. And so, of course, you know that you're learning best practices, and your code kind of turns out to look something like this. And when I graduated, I didn't want to code ever, because all of my code looked exactly like this. Debugging was a complete pain in the ass, because your variables are all named single characters, and there's loops upon loops. So I want to try to avoid that and try to point you in the right direction. You're not going to be able to learn everything today, but hopefully just pointing you in the right direction will give you the tools to be a competent on the DevOps stack. So, going back to our 3-tier infrastructure, what does this actually look like? Well, it wouldn't be much of an infrastructure talk without one of these. If this is the first time you've seen one of these, this is kind of a network system diagram, I believe is what the industry term for it. The majority of our time as web developers is spent in this key spot right here, setting up these web servers. This is the server that's actually going to host your Rails, your Sinatra app, whatever else you're writing. This is where the majority of our work goes, because this is what we've customized. The majority of the rest of the stuff, the load balancer, the database, that kind of thing, while you can customize it, and you do, especially as you grow, when you're first launching your app, most of these things are just boilerplate. You're just using whatever comes standard and pushing the on button. So the web servers is the most complicated piece. I'm going to spend most of my time talking about how we provision and build these in a way that doesn't make you hate yourself. Cool. So, first things first. The first step for our infrastructure is asking this question: how do I cloud? What is even the process? So if I want to get past that git push heroku master, what does it look like? So I thought of a bunch of ways that I could kind of explain this to you to the very new beginners. So I thought I would explain it the best way I know how, and that's through this visual representation. First, we're going to start with this Ubuntu layer. We're going to do some updates to make sure it's up to date. We'll do some basic server hardening, very standard stuff. We're going to encrypt the disk, install Ansible to help our lives make it a little better. We got Ruby on there, some Git. This is so disgusting. But the first time I saw this, I was like crying, laughing the whole time because I hate those stupid Facebook recipes. That in a nutshell is what we're in for. I want to teach you how to be able to give yourself a nice base starting point when it comes to building with your web servers. And what I want to show you first is the Web 1.0 way of doing this. And that's your standard, okay, I'm logging into Amazon, and this is me provisioning my server. Is this playing? So this is the Amazon Web Console. If you haven't seen this before, basically they say, okay, you want to rent a server from Amazon. How are you going to do that? Well, you can choose your base image. You're going to be a Windows box. You're going to be Ubuntu or whatever. And renting a server from them is dead easy. It's as easy as this video is making it. And when Amazon Web Services first launched, people lost their minds because this was so easy. We take it for granted now because this is just like whatever, another day in a life of a DevOps engineer. But back in the day, this was a big deal, and it still is a huge feat if you think about it. I mean, in 5 minutes, you have rented a server and have something that you can start off with from scratch, all from the get-go. So after you follow that process of actually creating a server from that GUI, you can SSH into it. SSH just basically means you're taking over the command line of that computer, and you can be able to run whatever you want. You can run Rails server, and there you go. You can run your Rails server on that web server you just booted up. pretty straightforward. I mean, I think most people who've kicked the tires with Amazon or DigitalOcean have gone through that exercise, and that works great. It's going to get you out the door. When I first started with Amazon, that's exactly what I did. I did everything by hand. Went through that GUI, clicked all the buttons, and spun up everything that I needed to. But I soon found out that there's two different options and two different approaches to DevOps administration. And this approach of doing everything by hand is a lot like raising these kids. These are my two little kids, two of my three. This is the most mischievous picture I could find of them. But doing everything by hand in the DevOps world is very unpredictable, just like these kids. You never know when they're going to trash something, when they're going to wake you up in the middle of the night because something is on fire. Sound familiar? It's very high stress. I mean, I'm a helicopter parent because I'm a millennial, and that's the way that we do things, I guess. I have enough of that in my home life. I don't need that at work. I don't need that with my Amazon stack. And so what I'm going to be teaching you for the rest of today is how to do this in a much more ordered fashion. And that's our second option. Looks something like this. This is from Inside Out. If you haven't seen it, amazing movie. This is an imaginary boyfriend conveyor belt. Only Disney would come up with this idea. But the whole idea is we want something that is ordered, that we know the mindset of every one of these little imaginary boyfriends. We know that they're going to die for Riley. They love her, man. And that's the mindset that we need our servers to be in. We need to know exactly what they're doing. We need to exactly know that they're repeatable, that nothing's out of control. It sounds like what the first option should have been, but after you do things enough on your own by hand, you soon find out that that's not the case, especially if you've put two things together that don't go well together. And so in order to get to this option, I'm going to teach you some cool tools that's going to get you there. And I have this very hipster slide to introduce my tools to you. And so prepare your mustaches with your wax. So we have Packer. Packer is a tool that helps us build our base image. So going back to that clone example, there was first, in the beginning, there was one imaginary boyfriend, and then there was a lot coming off that conveyor belt. Packer helps us build that initial clone, and then it enables us to spin up as many web servers as we need. And as we've learned through this conference, it's Rails, you're going to need a lot of them. Then next we're going to use Ansible. Ansible is a configuration management tool, which, how buzzwordy is that? This is going to help us do a lot of repetitive tasks really fast and take the manual component out of it. And then lastly, Terraform to help us to manage our Amazon stack in general. So let's start with Packer. So what Packer is really good at is not only building these server images for us, but also allowing us to do so with just about every player in the book. So in our one configuration, we can say, all right, I want you to spin out Amazon images, I want DigitalOcean droplets, Google Cloud Azure, or whatever, which is really great. And having open source tools like this that are flexible like that work really great when your CTO is really good friends with a VP at Microsoft, and suddenly you come to work and you find out that your AWS stack that you love and have worked so hard to work on just got taken over by Azure. Happened to one of my good friends recently, and it was not a great day because they basically had to start from scratch. So while there will still be a lot of rework of moving, this helps alleviate it a little bit because you're able to reuse a lot of your same stuff that you've used. So what does a Packer file look like? And now we're starting to get to the code. Packer can kind of be broken up into three parts. There's builders, there's provisioners, and there's post-processors. Our builders are specific to whatever we're using for the end game. So in this case, we're using Amazon. And so all of these configurations that you see here are specific to Amazon's implementation of dealing with base images. So you'll see here it's asking for the region. It's asking for this AMI name field in the middle. That's the key one because it's what is your AMI going to be named at the end of the day. And at the bottom, we have this source AMI filter. This is really cool because it will dynamically search in Amazon and say, hey, give me the most up-to-date Ubuntu 16.04. And it will give that to you. So you don't have to hard code anything. just in case Amazon releases an up-to-date version for whatever reason, security patches or what have you. You're not hard-coded into anything. You can use a lot more variables than I've used here. I kind of hard-coded this, a couple of these things like the VPC ID and all of that. But yeah, I'll go into that a little bit more later. If all of that seems like crazy talk to you, I'll explain in detail later. Okay, so the next step is the provisioner. So the provisioner is where all the really cool stuff that customizes your image to do the job that you want it to do. Sorry, I've got kids, can you tell from all of my pictures? So for instance, we want to run a Ruby app at some point in the near future in Amazon. Provisioners are what you use to tell your servers to get up to date, to install Ruby, all of that stuff, so that it can actually do its job. And in provisioners, again, the flexibility of this tool chain is amazing. There's a lot of them. You can use Ansible to provision your servers. You can use Chef. You can use Puppet. We'll go into Ansible and deep next, but long story short, these are some popular automation tools that DevOps engineers have loved and used for years. And so if you already use one of these in your organization, you can easily plug and play what you've already worked so hard to build on into this tool chain with very minimal work. I like to use Ansible, and that's what we're using here. There's also a file provisioner. So if you want to copy a file from a source destination to your server, so like an example for this would be like an Nginx configuration file. If you wanted to copy that and put it onto the images that you're building, you'd use the file provisioner for that. You can use shell to run shell commands. This is what I'm doing here with this first provisioner where I'm installing Ansible directly, or you can write your own custom one. And then next we have post processors. These are optional. I've never actually used them, but if you're using Docker a lot, this is a time for you to push your Docker image to like a Docker hub or something like that. If you have any centralized repository for your images, this could be a great place to use them. Now, since this is kind of technical and I think we have a little time, I think I'm going to pause for questions before I move on for any of these first three ideas with Packer. Does anybody have any questions before we move forward? Builders, provisioners, post-processors? Okay. Anybody? Go ahead.
What do you do with the ones that overlap, like Docker and Kubernetes?
Oh, yeah. Good question. So the really cool thing about...
Wait, what's the question?
Oh, sorry, yeah. The question was, what do you do about these things that overlap, like Docker or Kubernetes or things like that? And the answer is with Packer, it's so flexible that you can run them all in parallel, or you can choose whatever the best tool for the job is. I mean, we'll see a lot more of that overlap here in a bit, but my favorite thing about Packer is that if you work with people who are big Docker fans, then I get my Amazon image and you get your Docker image, and we're all friends and we're all happy at the end. Any other questions before I move on? All right, so post-processors. Okay, so what we need for our Ruby box is we're going to need Ruby, of course. We'll need Git so we can do a Git pull, right? So we can get our repository onto our server. We're going to need Nginx for our web server. We're going to need Postgres for our database. And we're going to need some of that sweet server hardening that our raccoon friend showed us. With the provisioners that Packer ships with, we could do all of those jobs very easily within Packer, and a lot of people do that with a lot of success. I do not like to do that because I prefer to use a tool that's specific for that job, and that would be something like Ansible. So at a high level, Ansible will help take a lot of the redundant and kind of repetitive tasks, like doing sudo apt-get installs, upgrades, that kind of thing, pulling repos, and they automate it and take all that redundant work and just make your life just, a breeze. It's a lot like this, except for it doesn't, try to kill you or suck. For instance, apt-get update, install Ruby, Git, all that stuff. And you can wrap all of those common commands into what they call a playbook, which looks exactly like this. So here's a real example of a playbook. This comes from our good friends at DevSec. They are a group that does server hardening, that kind of thing. I love to use their work. They do great work in the community because the last thing that I want to do is trust my security expertise against professional exploiters. So leveraging and standing on the shoulders of these giants, we're able to harden our servers and protect our client data as well. So from here, again, like Packer, there's a lot of different modules that Ansible can break down and do for you. They can do file transfer, they can do stat, you can check to see if files exist and operate conditionally. They can start and stop services, so starting and stopping Nginx from an Ansible, very, very good, easy thing to do. It can create users, create cron schedules, create groups, run shell scripts, all that fun stuff. And so again, so the big question is well, yeah, clearly, again, adding to Nick's question about when do you use what, the real reason why I like to use Ansible is this little secret galaxy. I love Ansible Galaxy. It is much like Ruby gems, except for instead of Ruby code that does things that I don't need to because it's already been abstracted, the Ansible community has different roles that have been abstracted by professionals, people who know the details of implementing Ruby, who know the details of setting up Postgres. They've already done all of that hard work, and again, I can stand on their shoulders and I can leverage my team to work a lot more efficiently. So going back to our recipe list, these are the things that we need. Using an Ansible playbook is as easy as this to accomplish all of those things. So on the left, we have our Ansible YAML file. Ansible is really easy to read. It's just YAML. You should be fairly familiar with that if you've worked with Rails before. And then on the right is the requirements file. So this is when it's kind of like a gem lock, if you're familiar with Bundler. We're saying I want to use these specific Ansible roles. These are the versions I want to use, and if I've got them to work at one point in time, sweet, I'm going to lock that down. And if I want to upgrade them, I can upgrade them one at a time in the future, a little less risky. Okay, so bringing it all together, if we wanted to build an image from Packer, this is what it's going to look like. We went over our builder already. Our provisioner, pretty straightforward. Sorry, it's kind of small. But the first step, I'm using a shell command to actually install Ansible locally. So I mean, even just doing that probably took me 30 minutes because I ran into version conflicts and whatever. Which is why I really love to use Ansible Galaxy because they abstract all of that for you. And then the last provisioner just says, hey, just run that Ansible script and you're good to go. Cool. So now it's the time and moment of truth. You guys ready for some live coding? Yeah. Are you crazy? Live server coding? I mean, I'm crazy enough to wear a cat shirt. Not that crazy. So you run a Packer build command, and then it does all of the magic. So this is it going out and creating a EC2 instance. So that it can actually run all of these scripts. So the steps are it creates an instance and then it creates a base off of that. So every new instance that you spin up is a copy of what you're making. It's that imaginary boyfriend that we're trying to clone. So what's really cool about Ansible is they take care of all the security stuff. They're going to create a temporary key for you. They're going to create temporary security groups for you. They do all that, and it's super slick. So what you're seeing right now is installing Ansible via that shell provisioner that we went through. Just a couple sudo apt-get commands, pretty straightforward. The nice thing about Packer and the bad thing about Packer is that if you ever do a Control-C, it will actually clean up really well for you. So if you realize you've made a mistake, you can hit Control-C. It'll kill your old instance. It'll kill your old AMIs if it was in the process of it. Cleans up really well because if you have one thing off, I mean, these things can take like 15 minutes to run sometimes, which is, Rubyists don't have a lot of I'm slacking because my code's compiling excuses, but working with Packer, you definitely do. So where are we at? So now we're going through it. It downloaded all of our Ansible Galaxy scripts, and now it's actually ripping through all of them. So if you're following along with this code, it's actually doing through all of that OS hardening stuff. Right now we're doing the Nginx install, Postgres. Again, I'm so glad that I don't have to do all of this by hand because the amount of the amount of worry that I had that, oh man, what happens if one day one of my servers goes down and I have to rebuild it all by scratch? I mean, you can kind of mitigate that by creating images along the way, but having something repeatable like this and transferable to other platforms is a huge relief. I mean, if you can take one thing away from this talk, learn to use Ansible or some other configuration management tool, because that will take the majority of the pain out of your experience with setting up web services. So, I mean, I sped this video up and it's still cruising. I mean, yeah, whatever. You guys are just gonna believe me that it created it at the end, right? I'm just a magician. Cool. So if you remember back, our goal and our objective was to create this 3-tiered architecture. So at this point, Packer's given us the ability to have a pretty decent web server. I mean, this isn't a complete thing. I mean, you still need to configure your provisioner to actually pull from GitHub, but again, that's super simple because it has shell provisioners in there, so you can literally just do a git clone and you're off to the races. But we've done most of the heavy lifting. At least I've given you the tools to do most of the heavy lifting. So we've done that part. And we've also already answered this question already. Again, because a lot of people love Docker. Docker's great. You know, for me, Docker, it works great for a lot of use cases, like especially if you're running like a bunch of microservices and that kind of thing, and you want to be able to host all this stuff locally. For me, I'm a pretty traditionalist, monolith kind of Rails architect style, and so Docker really didn't make a lot of sense to me. In fact, it got in the way a lot of the times. It was like this inception of there's a server within another server, and if I had to log into that server and do some debugging or modify the logs or whatever, tail some logs, like it was just a lot of DevOps work that even me, who gets excited about it, didn't want to do. So again, if your organization uses it, more power to it. I just prefer this type of thing because it's less magic abstraction and more like native, okay, this is just a computer that I'm dealing with here. Okay, so last but certainly not least, and what I think the coolest part of this tool chain is Terraform. I mean, it's got a pretty hardcore rock star name, right? So Terraform is a tool that you can use to write, plan, create your infrastructure as code. And if you're familiar with Amazon services, well, you'll be like, well, there's already something for that. They've got CloudFormation that does all of that for me. Which is true. CloudFormation is pretty sweet, actually, because you get the benefits of being able to make all of your infrastructure changes as code, but there are some definite downsides. Terraform does a really good job in keeping track of state and making sure that what is in code and what is actually in the console is the same. Because a lot of the times, especially when you're working with a team in infrastructure, people will log in and can make changes at any point. Terraform has some really good tools to make sure that both that state and the state of the code is actually in the same. And then, much like Packer, it's platform agnostic. So you can write this for Amazon, for DigitalOcean, for Google Cloud, all of that. And it's really hard to kind of explain the benefits to it until I actually show you. So we'll do that. And if you've got more questions, we'll come back. So this is where I'm going to take a step back and kind of address the newer crowd, people who aren't super familiar with networking terms, with system administration terms. And if you are familiar with those, just be patient with us. We'll get to the cool stuff in a second. But that's all of these Amazon services that we're going to have to spin up: VPCs, internet gateways, security groups, load balancers. That's a lot to handle, but it's not that bad when you have it all in one place and you can work with it in a chronological order. So going back to our 3 tiers, so what I want to do is I want to show you how to create all of these and explain the AWS service that correlates with each of these. Excuse me. So just real quick to remind everyone how the flow of a request from the internet to the database back to the internet goes. I know we've seen this a lot with the Rails request diagram, but this is from the networking perspective. So what will happen is we'll get a request, and then we have something called a load balancer that passes it to one of our many servers. In this case, I've just got 2, but I've worked with places that have hundreds for the various different services that we've had. So it just kind of depends on your needs. I typically run 2 so I can do 0 downtime deploys, but again, another topic for another day. Once your web server gets a request, it will actually ask the database for that cool cat GIF that you were looking for, pass it back to the web server, who will then to the load balancer all the way back out. So that is the anatomy of what we're going to cruise through real quick in Amazon. EC2 is where we started when we were actually spinning up those boxes. The first thing that you should be aware of when it comes to Amazon, and you couldn't even have got to the screen that we were at earlier to create images without understanding these. AWS regions are groups of data centers. So it's not even just one data center in North Virginia. It's going to be like 5 data centers in North Virginia. North Virginia was the first AWS region, and it's also the most popular because of that, and it also crashes the most. So if you are, and I think it's also the most expensive. No, I'm not going to say that. I don't know. So when you're starting, you need to pick one of these regions that you're going to work with. You typically want to do it for wherever your use case is closest to your users. So you'll choose a data center that you want to spin your stuff up on. The next step is a VPC. And I realized as soon as I created this slide that nobody was getting this joke that I was going for. So because it's a bad joke, I have another joke to explain it. So VPC is a virtual private cloud. So in this case, privacy, whatever, you know. So Amazon obviously has lots of clients. I mean, how many here are on Amazon right now? Raise your hand. So these are a lot of VPCs. Amazon clearly needs to make sure that this guy is not looking at this guy's looking at this gal's Amazon code. So they develop these private clouds so that when you are working with your resources, you're only working with yours. You're not accidentally going to bring down Netflix. So the next concept real quick is an internet gateway. So you have this VPC of yours on the right. So this is your cloud that Amazon's given you to rent. But by default, I don't think it's actually connected to this thing called the www. And in order to get that, you need a gateway that actually bridges the gap between those two. So time for code again. So this is Terraform, our first look at its syntax. It reads a lot. It's like this weird combination of JSON and I don't know what else. Whatever, it's Terraform. But it reads pretty cleanly, and when I've got some comments here, I actually took most of this code from their examples that Terraform gives you. In their code base, they've got a couple dozen examples of different architectures that you can work with. Really good, well commented, to explain to you how the Terraform stack works. So in this case, we're telling Terraform our provider is Amazon. We're not working with Azure or anything like that. And the other thing about Terraform is it reads very procedurally. So a lot of these Terraform files can be very long because things have to be created in a sequential manner. And we'll see why that's important here in a second. So after we've told them which region we want, we need to create a VPC. And then the next one is that internet gateway. And you'll see on this one, we're actually using a variable, this AWS VPC.default.id. And that's actually the variable that we're getting programmatically based off of the naming convention of the VPC that we created in this step before. So what's really cool is you can piggyback these names of these variables on top of each other as you grow. And then the next one is our internet access, again, closely related to what we were talking about before. Cool. So again, speaking to our newer system administrators, we're going to talk about ports. And you might recognize ports from other famous films such as localhost 3000. So if you boot up a Rails server for the first time, you might ask yourself, hey, what's this weird colon with a 3000 on it? And you probably figured out then that there are many different services that can run on one server, on your personal computer. And in order to get to the right one, you need to specify which port it is. You see, I don't know if this joke still has legs. I think it's probably a bit overdone. But communicating over ports is, I think, what's his name was trying to get across when he was saying the internets were a series of tubes. In this case, yeah, we're going to have two servers, one called Phil, one called Connors. Anybody know the reference? Groundhog Day, yeah, sorry. My references are all over the place today. So we're going to set up a one-directional tube between server Phil and server Connors. So Connors can't actually talk to Phil, but Phil can talk to Connors. And this is, and the important part is that this is based off of a specific port. So as you're used to using 3000 for local, other ports are used elsewhere to handle protocols. So they can be one direction, they can be two directional, whatever. Again, to help out our newer developers in the crowd, I want to go over some of the basic ports that are traditionally used. I mean, you don't have to use these ports for these services, but they're traditionally used. So they're going to be very basic for most of you. So if you know what service it is, feel free to shout it out. SSH. So that's that cool tool that allows you to command line into someone else's computer, hopefully yours. HTTP. And depending on the health of your neckbeard, CLS. Come on, guys. There's 3 different names for it, whatever. Those are the most basic ones for a web developer to know. You need 22 to actually get into your box, 80 and 443, 80 for HTTP requests if you want to encrypt it like a good citizen. 443 is your guy.
And 21 for deployments.
21 for deployments, cool. I love it. Okay, cool. So the next technical subject before I show you the next implementation is that of subnets. So if you remember back, we have our VPC, which is the 3 columns to the right. A subnet is a way of grouping that cloud to logical separated units. For instance, web servers should be on their own subnet and be on a separate one from a database, so that you're not having people YOLO take over your database by accident. And a cool way to make sure that doesn't happen is to employ security groups. I'm sorry, a really painful example. And then we already went over load balancers. Yeah, we get that. Cool, so here's the Terraform implementation of those concepts really quick. So here's us creating our subnet at the top example. We give it our VPC, we give it a CIDR block. Won't go into that yet. And then we're setting up a security group. As you can see here, this is a grouping of those port rules that we talked about before. So you remember how we set up that pipe between Phil and Connors of 3000. In this case, what we want to do is we want to open up port 80 from the internet to our load balancer so that our load balancer can receive requests from the internet at large. And the cool thing about using a security group, I mean, in this case, you can throw out as many load balancers in there as you want, and you'll need it as you scale. But more than likely, you'll want to have a security group for your web servers, because they're always going to behave the same way, and you want to give them the same permissions. And these security groups allow you to do that in a really quick fashion. And again, here's another example of one that we'll need. Here's us actually installing our load balancer. So if we want to be able to scale at web scale, then you'll need a web balancer to take care of all of those requests. I'm just going over port 80 here. I didn't want to make it too long or complex by throwing 443 in. And then here is where we're tying in our work from Packer. So this is us actually creating our web servers. In this case, we provide, or it listens for an AMI that we want to use. So this IDF is just kind of hard-coded. You can do some cool things like piping the output of our Packer file into some variable and reading that off here if you wanted to make this truly dynamic. But this allows us to say, okay, we're going to have web servers, we're going to have a couple of them, and they're all going to be based off of that same Packer ID that we built up from before. We're going to have a security group, its own subnet, and then last but not least, here is our database that we're spinning up. This is just an RDS implementation. RDS is Amazon's kind of their database management. So they will actually create and manage your Postgres implementations. And then, cool. So you survived all of the code to actually build our 3-tier infrastructure. Now we just have to come to the command line and figure out how we actually, build it. So just running Terraform in the command line after you've installed it gives you this. There are a lot of different commands here. This is really cool. I'm just going to highlight a handful of them. And the first one, and one of the reasons why I like this better than CloudFormation for checking your infrastructure and as code, is you can actually plan so you can see what the damage is going to be before you push the play button. So if I see this, it kind of gives me like a Git-like output, a Git diff-like output that says, okay, based off of your Terraform file, it looks like you're missing a couple of things. And everything that you're missing is going to come across as a plus sign and with the details of it below. So in this case, yeah, you're missing a database. We're going to give you a database. You're missing a subnet. I mean, this was a huge output. And I thought about showing it all to you, but we've done that a lot already. But you kind of get the idea. It tells you what you're missing, but that's all it will do. When you just do plan, it's not going to actually build or spin up anything for you. It's just going to say, if you actually do push that go button, this is what's going to happen. If you did actually want it to build, then you push apply. And apply is going to take that state, and the state is it's keeping track of what's been implemented on Amazon, and it's going to say, all right, now it's actually time to take the diff of our plan and what's currently in production and make all of that reality. So when you run apply, this is what the output will look like. It'll say, okay, I've created my VPC, I've created my subnet, I've created all of these things for you, and all you had to do was run that one command. I mean, you just blew it. Pretty cool, pretty cool. I mean, it's even more cool if you've done this by hand and you know the pain that it is to do each one of those services and go click through the maze that is their graphical user interface. It's kind of a nightmare. It gets better with time, but especially as you're starting out, I think being able to have something on this that you can check into Git and have version control history on, it's huge. So again, going back to state management, I think what's really cool about this is, say you've already got an Amazon infrastructure in place, which it seems like most of us do. If you're not using Terraform, you can actually run this command to import it. So you give it your credentials and it'll be like, oh, sweet, looks like you've got this, this, and this, and this. And yeah, and then from there you can make changes to that Terraform file as you see fit. Now, when we first introduced this architecture, that was a bad idea because so many people had tried their hands at the DevOps thing and nobody was really an expert at it. And so when we did that import command, we found a lot of skeletons in our Amazon's closet, and we realized, we're just going to build it from scratch. And the cool thing is with Terraform is it makes that super simple. The other thing is again, if you're working with a team and people are still doing things on the console even though you prefer to do it in Terraform, if you do this refresh, then it will actually update the state of your Terraform stack to be able to say, okay, it looks like this Joker created these AMIs that you weren't aware of, or sorry, these web servers that you weren't aware of, which I think is really cool. So last but not least for our Terraform tour is Terraform Destroy. So how do you burn it all to the ground? Which is actually really cool because at a touch of a button, if you wanted to turn whatever you were working on off, you easily could. So if you work with, I don't know what type of environments that you work in, but we typically we code on our developer machines. We have a shared staging environment and we have a production environment. A lot of times that staging environment gets kind of blocked up because everyone's trying to push their code through. And what happens if somebody messed something up in staging and couldn't fix it? Well, with Terraform, you can easily copy your staging environment, and every employee could have their own. And they can only rent those services from Amazon for as long as you need them. I think that's really cool. And as soon as you're done working with it, you just run the destroy command, and it's all gone. So my experience with Terraform was kind of like this. When I see that Terraform plan command, and then the apply hits, I'm like, holy crap, this is sweet. And then my bill's like, oh yeah. That's kind of the danger of it, because you can spin up a lot of stuff really fast. Just make sure you run that destroy command, otherwise you're going to be in for some pain. So some other cool use cases. So we have a control at my work where we have to upgrade our servers for security vulnerabilities on a monthly basis. So this is what used to take us a day to do, now is just a shell command that we run, where we say, all right, all of our web servers, we need to take our base image that has all of our provisioners to put our app on and all that stuff. We just want you to go do an apt-get update upgrade, and then throw that up, and then we'll see that in staging. If it works, then we just run another command to slowly phase out all of our production servers with these new ones. Way slick. I don't have to touch a console. Way easy. I already talked about this use case. Disaster recovery, this is a big one. So this was something that kept me up a lot because I was solely in the US West East 1 region, which, like I said before, can sometimes be problematic. So with using Packer, you can actually tell it to say, hey, create this image both in Virginia and in Oregon. And if you've got that and you've got snapshots in both places, then you can easily run that Terraform apply command in Oregon, and you have all of your Amazon infrastructure in 2 places. And as soon as the East gets its stuff back together again, you can pass it back. Or just make Oregon as your primary host until something bad happens there and you can flip-flop. Super easy. And I think that's all I've got. I would highly recommend checking out packer.io, ansible.com, terraform.io. Their docs are amazing, and their examples are great. If you're interested in picking up where we left off today, this is the GitHub profile for all of that. Having said that, I know that was a lot of content, but I'm happy to field questions if you've got them.
Is there a reason you use Packer instead of just using Terraform and Ansible?
Yeah, the main reason why I did it is for that plan, apply, really, Ansible could take care of all of that if you wanted it to. Yeah, good question, and I'll repeat it for those who didn't hear. So they wondered why do you even need Terraform if you have configuration management tools that can take care of all of that?
Why would you use Packer if you could use Terraform to provision or to provision your servers and then call into Ansible to then configure them?
Oh, yeah, good call. I mean, really, I guess I could. I don't know if Terraform comes with an Ansible provisioner. If it does, then sweet, maybe I can kill a step. But I like it because I've worked with a lot of Docker people, and the cross-platform functionality of it's really appealing to me. But really, you could. I mean, all of these tools, they have very blurred lines of responsibility, and it's kind of up to you to choose your own poison and your own adventure, right?
Yeah, to that point, because Packer, of course, generates the AMIs that are used as your base images on Amazon. I think if you were doing that, you're basically doing the Ansible setup ahead of time instead of spinning up an EC2 server, then applying Ansible configuration.
Oh yeah, that makes a lot of sense.
Kind of cut down on that initial setup time if you're keeping your AMIs up to date.
Yeah.
That's one way that you might have a choice to, Packer may make sense depending on how long your Ansible setup times are.
Got it. So if you didn't hear that, one of the big reason for Packers, it saves on your spin up time for creating the base AMIs. Like I said, like you saw the video, even though I spun it up by like 3,000%, it still takes a lot of time. So if you have to run that in line with Terraform, it can slow you down a lot.
You can do all this just by writing shell scripts, and so
So see, that's where I started. I started doing shell scripts, and you easily could. And if it works for you, awesome. I prefer that Ansible Galaxy step so that I can let the pros who write those shell scripts do it for me. So I can just offload some work to them. I mean, again, the reality with this tool chain, you can do whatever's flexible, whatever works for you.
Just to that point, we could do all of our work in assembly. Higher level abstractions make things more simple and manageable, and that tool chain in particular has been awesome for us.
Yeah.
Except those abstractions just leak, and then you've got to deal with cold players. I don't know. I'm biased. Every time I've used Ansible, I end up running into that one thing where you have to use Ansible's command line, which is just a bash execution. And I have bash script in my Ansible thing, and I'm dealing with both layers of abstraction, and it's not declarative anymore.
Yeah.
And I've got imperative code in my beautiful declarative universe, and I don't know. I just think that's personal.
Yeah, I'm kind of in your camp still. I feel like that might be a fault of my own, but like I've tried Puppet a long time and Chef. I haven't really tried Ansible, but I felt really similarly to it.
Yeah.
The one thing I've found is that like with Chef, because that's what I use just Terraform and Chef, is that I can unit test my cookbooks, and I can create a bunch of recipes into bigger cookbooks in smaller pieces. So when they release an update on version, say Mongo, for example, and I want to go from 3.0 to 3.2, then I can create a new cookbook and promote the chain. I can make sure that my environment follows my code. So I can upgrade it the same way, roll it out, prove it out through development to staging, and not only have unit tests that prove it out both ways, but integration tests too, with Chef in the kitchen and other pieces that will actually spin up the server so we can test it all beforehand. And the Chef, because I have to go into bash every now and again for some stupid parts. Couch 2.0 is one that has a done with installing. So you got to work around it, but overall I found, because I came out of IT, I'm a developer, no still me. But I came from this and that route, and going from where I used to install base metal to this, it's
Yeah. Cool. Any other questions? Go ahead.
Well, just comment, you know, how you talk about hardening your stack. One thing is keeping it hard, right? Once you stand it up and it's great, you came off the assembly forms and your imaginary boyfriend. But eventually things happen and your imaginary boyfriend is what you thought it was. So like, one thing where you can kind of manage that configuration group.
Yeah.
Like, so you stay hard.
Yeah, exactly. So and that's a great point, and I think